Hello everyone, today we will tell you about the project assignment of the dynamic course. The project name is NOVA. In this project, we will examine the escalations and the engineers use it and make the necessary calculations. While preparing in this video, we used the simulation video on the Jared Owen YouTube channel and made our measurements on the escalator in various shopping center and metro line in Bursa.
In this project, the motor power requirement of an escalator with a 28-degree inclination and a length of 11.3 meters is calculated under maximum passenger load. Assuming 75 kilograms per person and 0.4 meters between steps, the maximum number of passengers on the escalator is determined. The structure's own weight is taken as 225 kilograms per meter, resulting in the total moving mass. The system operates at a constant speed of 1.145 meters per second with a tangential acceleration of 0.277 meters per second squared. Based on these parameters, the motor must generate enough force to overcome gravitational force, provide acceleration, and compensate for friction losses. All these components are combined, and considering 80% motor efficiency, the total required electrical motor power is calculated.
Using the free body diagram of an escalator. The global coordinate system is xi and the local one is tn, which follows the slope. Each person has weight force W acting down in the y direction. In tn coordinate, this becomes this equation. The motor pulls the escalator in the t direction with a force T. This T force moves both the escalator and the people up. But there is also internal friction in the motor, which causes energy loss. There is another friction force between the steps and the rail, acting opposite the motion. Also, every step pushes down on the surface, and the surface gives a normal force N in return. The escalator's own motion also causes friction. Even if the number of passengers and total weight change, the escalator keeps the same speed. In the next part, we will see how this is possible.
In the second part of the study, the motor's power over time is analyzed. During the first 3 seconds of acceleration, the motor produces eager power because it must both accelerate the mass and work against gravity. After this period, the system reaches constant speed, and for the remaining 27 seconds, the motor power remains steady. This is because the motion continues at constant speed, and the motor only needs to overcome gravity and friction. This variation is visualized as a time-based graph, clearly showing how the motor starts at a power level and stabilizes. Additionally, all power components in the system are presented in detailed row, bar and pie charts.
In our presentation, we explained how to calculate the motor power of escalator and conducted a sample motor power calculations based on a specific escalator. Thank you for listening.